And so our next speaker is Brendon May from Carl's Lab.
Hi, I'm Brendon. I'm like she said, I'm from Carl's Lab, and my project is a little bit different probably than most because I didn't design a specific project, but I wanted mostly to talk about the three main projects that I assisted with. So the first of those is the Mesquite Lake long-term monitoring. As you can see from this map here, so AWRI is right here. So then there are 4 sites here: Fisherman's Landing, the Mesquite River site, Johnson's Point, which we call the AWRI because it's across there, and then the state park. And so at each of these 4 sites, we have a database stretching back about 19 years, and we've been setting pike nets there. We've been taking some water quality with the YSI sound, and we've also been doing some night electrofishing, which I'll talk about later. And then up here, these are 2 of the most common species. Up here we have a rock bass, and right there is a pumpkin seed, sunfish. And the data shows that these are 2 of the most common species, and they're also make up the most common family by far. The Centrarchidae are the most common family in our data set. And then over here we have the most common species, which is the yellow perch. We have, over the course of 19 years, we have about 28,000 species or fish total, and yellow perch make up about 4,000 of that. So it's a pretty comprehensive data set. You can see there, that's me and Matt doing the setting of the pike net there. And I've also got, in my left hand there, I've got the YSI to take some water quality readings. These water quality readings range from conductivity. We do all the oxygen, we do temperature, pH. And some of the main applications of those water quality readings are we can look at those, and then we can look at fish that had high recruitment in certain years, and we can sort of look at some of the indicators for why these fish were so common in certain years and why they weren't in other years. So for example, you can take something like, for bowfin, they're positively associated with turbidity. So as turbidity increases, the capture of bowfin increase. You can also go by site. So if we were to go back the map there, if you look at Johnson's Point, that is by far our highest site for round goby, actually. And they're also, round goby are also positively associated with spring sampling, which is pretty interesting. But there's a lot of applications that we can look into on that. And actually, that is one that I've been going to look into, which I'll get into later, but I'll be looking into that for my senior project, which I'll talk about later. So then the other aspect of that is the electrofishing. And as you can see, I've got a pretty nice sized largemouth there. And that's one of the good things about electrofishing. So you, the range of fish that you get is quite a bit different from the pike netting. So it tends to sample more heavily towards the larger fish. It tends to sample against smaller fish, especially fish like goby, which don't have swim bladders. So when you stun them with the electricity, they just sink to the bottom. And there's some other fish that it selects for against. So it's interesting. Carl's got a good paper on that, the differences between the 2 types of sampling. And then here's that largemouth bass senior project that I sort of went through a little bit earlier. Those are the H0 largemouth bass on the right over here. And H0 just means fish that were born in that sampling season. So for largemouth bass, that is, they're usually born late April, early May. So these fish are about 2 months old, and we captured those in the summer sampling from Mesquite Lake. And with this project, I would like to, it's still in the early stages, but I would like to look at the recruitment numbers for those largemouth bass. So what makes a good year in recruitment for largemouth bass, whether it's, literature suggests that it might be high dissolved oxygen rates, it could possibly be increased vegetation cover, which we also look at, or it could even vary from site to site. I would also potentially like to look at the rates of recruitment for largemouth bass in Lake Macatawa, which is a similar data set for, and see, because that's a more eutrophic lake, so I would like to maybe compare that with the Mesquite Lake data set. So that brings us to the second project that I worked on, which is the Great Lakes Coastal Wetland Monitoring Program. You can see that's the biggest fish actually that we captured in the year. It's a nice, I think it's 83 centimeters, so northern pike. And we actually captured it in that net. That's the we set that net in a frag vegetation zone, so the thing with Phragmites. So the thing with this program is you set the nets in specific vegetation, and there's 4 vegetation types. So for this one, it was Phragmites, and then the other ones that I did were lily, bulrush, typha, or cattail, which you'll see later. So the water quality differed a little bit. We also took those YSI readings, but then we took water quality samples from each of our sites and sent them to the lab. And then also there on the right, you can see those are, that looks like it's the air temperature logger, and then they also have a water temperature logger and a dissolved oxygen logger. So those look at the changes in the 24-hour period that we have those nets set, which is some interesting data there, especially with the dissolved oxygen, because it drops so much overnight. And the second aspect of this is the macro sampling, where you can see there we're picking through macros in a type of zone. And that can be an interesting aspect, because similarly to fish, there's certain macro species that are indicators, which Taylor talked about a little bit. There's certain macro species that are indicators of poor water quality, such as in our study, mainly leeches and chironomids. And then there's also some that we capture, such as certain species of mayflies, some stoneflies especially, that are really good indicators of a good water quality. And finally, the setting of spike nets, I sort of already talked about this. It's a similar protocol, but we set it in multiple different zones of vegetation. So the one on the left there is a typha zone, and the ones on the right there are a lily zone. And then we retrieve them and we mark the fish for species, and then we take the lengths of the fish. So there I am with a large common carp. In the top right over there, I have a long-nosed gar. And those are 2 of the most common larger species of these wetlands. And then over here we have as a yellow bullhead there. Top right is a bowfin. Those are 2 very common species, especially in more less oxygen-rich areas, which is some of the vegetation that we set in. And that is, bottom right is an unknown Locomus, which we got a lot of in a single day. We got about 2,500 of those in a single day, so that made for a lot of big. And so there's a lot of applications that they can use, similar to the Muskegon Lake stuff. Carl actually published a paper on this back in 2018 about an index of biological integrity. So they designed a biological integrity index for specifically this project. So they looked at each of the plant zones at a certain site, and they took several factors. Like one of them was the diversity of species, and there were also certain species that were weighted more than others. So like bowfin, for example, are indicators of low dissolved oxygen, and then there's other species that are indicators of good water quality, like log perch, for example. And so they looked at those and they assigned them a score based on the rating. The higher the score, the less impaired the water system was. And that brings me to the third project, which I actually just started this week, and I'll just briefly talk about it. It's still ongoing, but this is Nick's thesis project. You can see that the map on the right, that's of his the Boardman watershed. So we have 18 sites that we're going to backpack electrofish and do habitat assessments of. And then he's got 10 that he's already set the temperature loggers for. So the main goal of this project is to provide a habitat assessment and marking the captured backpack electrofishing. And it's to determine which of these stretches are most suitable for grayling reintroduction. So grayling were a extirpated species stretching back almost 100 years, and they're trying to reintroduce them into this watershed. As you can see here, these are the 2 most common species that we've been catching. That's the brown trout, and that's a brook trout on the bottom. That actually comes into play because the brown trout don't coexist very well with grayling. They're much more aggressive, and they push the grayling out, which is an interesting factor. And there's a ton of habitat assessment factors. The main one is probably temperature. Grayling for colder waters. There's a ton of bank assessment. You can see me there. I've got the flow meter, which measures the rate of flow of the water. And then also we record the sediment types. So grayling prefer gravel and coarse sediment. And yeah, I can't wait to keep working on that project. It's been really fun the first week, and I'd love to talk more about it. But and then yeah, I'd like to acknowledge first of all Carl for helping out a ton. He actually got me introduced to this institute. I found out about it through his class. I'd like to thank Matt and Nick for being a huge help. Nick's not here, but Matt was in charge of the Great Lakes Wetland program, and then Nick was in charge of the Organ project. And they've been a huge help for getting me started around here. And also, yeah, I'd like to thank you for letting me on to the programs. I'd like to thank Travis too, who's not here. He helped a lot the first week, especially with the mosquito monitoring. And I'd just like to thank everyone in the AWRI for making this a great summer. So thank you.
Questions for Brendon?
Yeah.
So, and I think you may have alluded to this, like in one of your later slides.
Yeah.
But for Centarchids, if it's one of the biggest families that you find,
Yeah.
they exhibit a lot of hybridization, right?
Yeah.
So bluegills can hybridize with pumpkin seed and green. So how do you, is that where you just say unknown locomus when you mark them? Because
That's
you're
part of
like,
the problem.
it's
Yeah.
got traits of every single.
Well, these ones were so the one on the bottom right here. Those ones are so small that at that point we can't even tell if it's a pure sunfish or we knew they were either sunfish or bluegill.
Right.
But at that point we had to take them back to the lab for assessment.
Yeah.
But then a lot of those bigger species do exhibit traits. So like it'll have, the mouth that's much larger than a pumpkin seed. So it's like the size of a green sunfish.
Right.
But then it will have it'll have like a spot at the back that looks like a bluegill. So yeah, some of those are very tough. That's probably the toughest for activity for sure.
Yeah, and do you just mark it as potential hybrid, or do you just go like locomus?
Yeah, with the bigger species, we'll take pictures of it, key identification marks, and when possible, we'll take it back to the lab. We'll put it in formaldehyde, take it back to the lab, or formally take it back to the lab. I know Matt's got a lot of fish to go through here, so good luck on that. Yeah, it's gonna be fun. Sorry. Any other questions?
Thank you.